Here is another great example about how we interpret the limit of a function as x approaches a particular value. For example, look at this function right here, g of x. According to the way in which this function has been defined, g of x is the quadratic x squared, the simple parabola x squared, whenever x does not equal to 2. But if x happens to equal to 2, g of x is going to be equal to 1. Graphically, how will that look? What I'm going to do right now is I'm going to sketch x squared, just simply x squared. We learned how to sketch x squared a long time ago. So I'm going to start with 0. When x is 0, 0 squared is 0. When x is 1, x squared is 1. When x is negative 1, 1 again. When x is 2, I am not going to put a dot. I'm going to put an open circle because remember how the function has been defined, that if x is 2, the value of the function is not going to be 2 squared, it is going to be 1. So here at 2, I am going to put an open circle indicating that the y value of this function is not going to be on the parabola. When x is negative 2, then the y value is going to be 4. So that point is going to be there. So the graph is going to be in a U shape, like that. And then in the other direction, again following the typical U shape of a quadratic function. Then when x is equal to 2, right here, we know that the y value is going to be 1. That means that there is going to be a closed dot, a dot that is just floating within that xy plane. Nonetheless, this is the entire graph of g of x. The graph of g of x consists of this parabola with an open circle at x equals 2. And then at x equals 2, we have to have a dot right here indicating that when x is equal to 2, the value of the function is exactly 1. The y value is 1. So then, obviously, something very interesting is happening at 2. I will even circle that. I will just circle x equals 2 there, because this is showing that when x is equal to 2, the y value is not as predictable as we would hope. The y value is not equal to 4. The y value is equal to 1. From the point of view of a limit, though, we don't care what happens at 2. We only care about what happens around 2. So for example, when x is approaching 2 from the left, I notice that the y values, let's look at the y values. I notice that the y values, let's say, of the function lie on the parabola. Then, when x gets even closer to 2, the y values are climbing a little bit higher up. And then the closer I go to 2, the higher the y values are getting on the parabola. And those y values, notice that those y values are approaching the circle, the open circle that is on that parabola. And that open circle happens to be at the same level as y equals 4. Similarly, in the other direction, as x approaches 2 from the right, when I take this x value right here and I go up to my graph, that takes me somewhere there. Then, as x is getting closer and closer, the y value is a little bit now lower. Then x over here gets closer to 2, the y value is getting closer to the open circle. Then I continue like this, and you can really see now, hopefully you can see that the y values are also getting closer and closer to the level of 4 right here. even though, let me remind you, even though the y value at 2 is exactly at 1, when x is approaching 2, the y values are approaching 4. They're not approaching 1. The y values are traveling along the parabola. So along the parabola, the y values are right here approaching 4. They will never equal to 4. But from the point of view of a limit, we don't really care what happens at 2. We care about what happens around 2, in a small neighborhood around 2. And in a small neighborhood around 2, let's say right here, the y values are getting closer and closer to 4. I wanted to show you here with my graphing calculator. I went ahead and I plotted the function and I looked at the table feature. I wanted to see what happens around 2. And notice how around 2, when x is equal to 1.9, so we are on the left of 2. The y value is 3.61. And then as x gets closer and closer to 2, 1.9, 1.99, 1.999, look at the y values. They're approaching 4. Then I went and I took x values to the right of 2. So again, we're getting closer and closer to 2, but from the right. 2.1, 2.01, a little bit closer to 2, 2.001, even closer. And I want you to look at the y values. Look at them. From 4.41, then to 4.04, 4.004. So clearly, again, the y values are approaching 4. At 2, when x is equal to 2, the y value is not equal to 4. But we don't care about what happens at 2. We only care about what happens around 2. And as we get really, really close to 2, the y values are getting closer and closer to 4. And that's what we want when we talk about limits. That's what makes 4 the limit of this function as x approaches 2. The fact that as x approaches 2, the y values are consistently approaching 4. So symbolically, we're going to say that the limit as x approaches 2 of the function, actually it's not f of x, it's g of x, that limit is going to be equal to 4, not to 1. Because the y values, again, I know that I'm repeating myself, but I really want to make this clear. As x is approaching 2, so x is not equal to 2, but x is really getting close to 2. The y values are the y values on the parabola. And those y values are getting closer and closer to 4. Notice how we are approaching the open circle, and the open circle is at 4. And that's what the limit is concerned about. The limit a function has a limit if the y values are approaching the same number. So x is getting very close to 2. The y values are getting very close to 4. So then we say that the limit as x approaches 2 of the function g of x is equal to 4. And this is very striking because this is really showing that the limit of a function as x approaches a number doesn't have to be equal to the y value. So my function can be perfectly defined at x equals 2. Like in this case, at x equals 2, the y value is 1. But the limit of the function at 2 is not equal to 1. It's actually equal to 4. So this is something that is unexpected as we're learning about limits. And something that I really want you to see and to feel comfortable with, that even though we know that g of 2 is equal to 1, the y value is equal to 1 when x is equal to 2, great, that's great. But that doesn't mean that the limit at 2 has to be 1. The limit is all about what the y values around x equals 2 are approaching. And the y values are approaching 4. They are not approaching 1. So this is why the limit as x approaches 2 of g of x is not equal to the y value. As we said above, the limit as x approaches 2 of g of x happens to be equal to 4, not to 1.